Hello there, Year 3, and welcome to the Set B set of questions for forces. So, last week we looked at Set A, and we went through the questions for that one. So, this week we're going to be doing Set B. Now, I'm aware that obviously last time I read this to you was last week, so what I've decided to do is to basically show you myself reading the text to you again from the previous video. I'm going to put that in here in a moment, and then we are going to get on with the questions. So, here we go. I'm now going to show you me from last week reading the text to you, and then we're going to get to the question. So here is me reading the text. There are many ways to explain what a force is. Perhaps the simplest way to think of a force is as something that can make an object move from one position to another. If an object is not staying still, there is, or was, a force that caused that movement. What is more, the object will continue to move until there is another force working in the opposite direction. Many forces are easy to spot. There are ones involving pushing, like when you are rolling a giant snowball to make the body of a snowman. There are also ones that involve pulling, such as a team of huskies with a sledge. In both cases you can clearly see who or what is doing all the work. It depends on whether they are behind or in front of the object as it moves. There are, however, some forces that you cannot see at all. We don't mean things like the wind in the sails of a boat. That force is invisible because we can't see air, although we can still feel it. No, we're not talking about things like gravity, the force that pulls objects towards the centre of the earth. You can't see it, you can't feel it in the same way you can sense the brush of the breeze through your hair. However, you will certainly know about it if you've ever lost your grip on the monkey bars. Magnetism is another force you can only notice by the effects it has on certain materials. It's almost magic the way a magnet can pick up a nail, let alone the way it can still work through different materials. Have you ever seen iron fillings moving around in one piece of card because there is a magnet shifting underneath? If that's hard to wrap your head around, magnetism can be both a pushing and a pulling force at the same time. It all depends which end or pole another magnet is closest. We call these opposite ends north and south. The north pole will attract the south pole of another magnet, but repel the north. So, if you have a magnet and you know which way round the poles are, you can also work out which is the north end and which is the south of any other magnet, just by moving it close enough. The proof will be in the pudding, as they say, or rather, the pushing or the pulling. Okay, and now we're back. So we're going to get straight on with the questions. So I'm going to go right into the vocabulary section of question 1. Here we go. Question 1. Look at the first paragraph. Find and copy a word that means carry on. Look at the first paragraph. Find and copy a word that means carry on. So we're going to look back at the first paragraph. Is there a word that means something like carry on? Many ways to explain if an object's not staying still. There was. Yep, there it is, right at the end, last sentence. What is more, the object will continue to move until there is another force working in the opposite direction. So the word I'm looking for there is continue. Continue is what I'm going to write down. That's your number 1. Question 1. Right, question 2. Look at the paragraph beginning, magnetism is another force. Which two words in the last sentence have the same meaning? Look at the paragraph beginning, magnetism is another force. Which two words in the last sentence have the same meaning? So we actually know the sentence we're looking at this time. So the magnetism is another force. I'm looking at the very last sentence of that section. Have you ever seen iron fillings moving around on a piece of card because there is a magnet shifting underneath? So I'm looking for two words that mean, have the same meaning. Two words that have the same meaning in that sentence. So it's going to be, I can actually see them together actually. There's one above, one below. It's moving and shifting. Moving and shifting. Those are your two words there, moving and shifting. Right, number 3. The North Pole will repel the North. Which group of words means the same as repel in this sentence? The North Pole will repel the North. Which group of words means the same as repel in this sentence? So is it easily remember, not like, pull towards, or push away? Now I did actually explain this one in the last video, if you can remember, that attract means when two magnets come together like this, they attract, and when they repel, they push away from each other, okay? So actually, if you remembered from last week, it is push away. Okay, push away is what happens when the north and the north go together, because they're the same, they push away. Okay, it needs to be two opposite ends of the poles to attract. Right, retrieval, question 4. What does the text say will make the object stop moving? What does the text say will make an object stop moving? So, let's have a look. Something about an object stopping moving. Let's just see here. So, right at the start, if an object is not staying still, there is or was a force that caused that movement. What is more, the object will continue to move until there is another force working in the opposite direction. That's what the text says, isn't it? Okay, so to stop an object from moving, it's when the object will continue to move until there is another force working in the opposite direction. So when another force acts in the opposite direction, that is when an object will stop moving. Okay. Question 5. What was given as the example of a pulling force? What was given as the example of a pulling force? So we had a similar question to this last week, where we had a picture of somebody pushing a snowball. This time it's asking us for the other one, isn't it? So what was given as the example of a pulling force? We can actually see it right there. It's labelled pulling force. It is the huskies pulling, isn't it? Okay, or the two dogs that are pulling. Okay, the huskies pulling a sledge is your answer. So that's your example. Right, question 6. Name 2 objects that the text says would be attracted to a magnet. Name 2 objects that the text says would be attracted to a magnet. So again, objects that the text says, not objects that you think would work. Not asking what you think or what you think it might be, okay? Nothing to do with that. What does the text say? You need to get examples from the text. Okay, this is where children often go wrong and they just go, oh, well, yeah, I know that is that one. Okay, no, use the text. Always use the text. Okay, so I'm going to have a look through here. What would be attracted to a magnet? It's going to be in the magnetism section. It is going to be materials. It has only almost magic way a magnet can pick up a nail, let alone it can still work through different materials. Have you ever seen iron filings move around on a piece of card because there is a magnet shifting underneath? So basically it's going to be any two from a nail, iron filings or other magnets. Okay, that'll be fine. But yeah, probably the 2 common ones are a nail or iron filings because they're the most common ones there, the first 2. But yeah, another magnet could also be moved. If you had one magnet in my hand and the magnet up here, if I moved it, it should move the magnet like this. Okay. Right, so we are on question 7. Inference. What does the text suggest is unusual about the forces of gravity and magnetism? What does the text suggest is unusual about the forces of gravity and magnetism? So, basically, it is, if we look back at the magnetism section, it is that magnetism is another force you can only notice by the effects it has on certain materials. Okay, that is going to be what it suggests about the force of gravity and magnetism, is that it can only be noticed by the effect it has. Okay, so basically what it suggests is you can't see them, isn't it? Okay, you can only notice it by the effects it has. So what is it suggesting by that? It's suggesting that you cannot see them. Okay, you can only notice magnetism by the effect it has, so you can't actually see them. It's just the effects it has, so you can't actually see them. That's your answer, is you can't see them. Question 8. It's almost magic the way magnets can pick up a nail. Explain why. It's almost magic the way a magnet can pick up a nail. Explain why. So the text does say this, doesn't it? It says it's almost magic the way a magnet can pick up a nail. But why is it almost magic? Why is that magic, or seeming like magic, or described as being like magic? Okay, so, well, if you've ever done this before, you might well have done this, or had a magnetic board game where pieces can move and you move the magnets around and they move about. I definitely used to have a magnetic board game. I had magnetic chess and all sorts of things. But yeah, basically, it's almost magic the way it can be picked up, because it's again going back to the fact you can't see it, isn't it? It's back because you can't see it happening. It looks a bit like a magic trick. So let me just check what I wrote here. How did I word it? Question 8. I said because it looks like a magic trick, or because you can't see how it's being done. Okay, so because it looks like a magic trick. If you can basically have a magnet, if you've never done this before, it's really difficult to explain, but say say my fingernail is the magnet, okay, and I've got a magnet in my hand here, and I move that magnet, it should move that magnet like this, okay? So wherever I move it, it should follow, and it looks like if it's on the actual surface, it would just be moving along like this, and it looks like nobody's touching it and it's moving. So it looks like magic, okay, but it's not, it's science. So there you go. Right, question 9. The proof will be in the pudding. Which group of words best explains what this means? Tick 1. So we've got another saying that's in there, okay? The proof will be in the pudding. So what does that mean? Does it mean you won't know until you try? Does it mean puddings are magnetic? Does it mean you need to heat the magnets? Or does it mean the answer will be hidden? So what does that mean? Well, the proof is in the pudding. Again, it's a saying that people usually use in conversation. The proof is in the pudding. It basically does mean, I'm just going to have to tell you because it's one of those ones you just have to know, I'm afraid. It is the one that says you won't know until you try. You won't know until you try. The proof is in the pudding, okay? Basically, the expression sort of comes from, if you look at a pudding, you think, oh, doesn't that look tasty? You don't know it's tasty until you've actually tried it. It might look tasty, but it might not be. And when you actually try the cake, or the pudding, whatever it is, you taste it and think, oh, actually, don't know about that. Okay, so the proof that that is actually good is in the pudding. You actually have to try it. Okay, that's what the expression means. The proof is in the pudding. But sometimes you might look at it and think, oh, that looks awful. You try it and think, wow, isn't that brilliant? Okay, which is why, incidentally, when you do have food, you should always try everything before you actually say you don't like it. Always give it a go first, and then you'll see if you actually do or don't like it. But definitely try it. Proof is in the pudding. There you go. Question 10, summarising. Using the whole text, tick one box in each row to show whether each statement is true or false. Using the whole text, tick one box in each row to show whether each statement is true or false. So, all forces are easy to see. Is that true or false? I really hope we know the answer to this one because we've read it very, very much in depth. That one is obviously false. Obviously false because we know we can't really see all forces, can we? Some of them are like magnetism, where we can move an object and we can watch it being moved. So no, they're not all easy to see. We can usually only see it from the effects, okay? Some forces like pushing and pulling, you can see the person doing the action, but not all of them can be seen, so no, they're not all easy to see. That is false. Next one, magnetism can be blocked by paper or card. Magnetism can be blocked by paper or card. Well, it does describe about paper, doesn't it? But that's where we have a magnet in between a sheet of paper and we can move another one underneath. It's not being blocked by it, is it? If anything, the magnetism is able to pass through that piece of paper. So that one is false. Paper does not block magnetism. You can still move a magnet through paper. That is false. And the last one, the north pole of one magnet will pull towards the south pole of another. The north pole of one magnet will pull towards the south pole of another. So remember what I told you about two magnets? If you've got one north pole and one south pole, they should attract. They attract, don't they? Okay. So it will, if you've got a north pole and a south pole, the north pole should pull towards the south like this, or the south might pull towards the north, but they attract each other. So yes, that is true. So it should be false, false, true. Right, question 11, authorial intent. The brush of the breeze through your hair. Explain why the word brush was used. The brush of the breeze through your hair. Explain why the word brush was used. So the word brush, basically, it's kind of a nice way to describe the breeze, isn't it? If you imagine brushing your hair, I don't have much hair, but if you're brushing your hair, okay, it's kind of like the way the wind might pass through your hair, isn't it? It's describing the way it might work. So like a brush, it's sort of like soft and gentle, the way a brush might pass through your hair, okay? So let me just check what I wrote. I said, because the wind passing through your hair is being described as gentle like a hairbrush. So there you go. That's explaining why the author decided to use the brush of the breeze. Okay, because it's being compared to a hairbrush, isn't it, going through your hair. Right, question 12, compare. How are gravity and magnetism A, different from each other, or B, similar to each other? So I'm going to have a look through here and I need to find something about it being similar or different. So how is it different from each other? Well, it is different because if you look in that paragraph here, just underneath the pushing and pulling force, it says that gravity, the force that pulls objects towards the centre of the earth, that is basically telling you the difference there, isn't it? It's basically saying that gravity, because gravity, what it does is it pulls things down, whereas magnets can pull things in different directions. Gravity is always pulling things down. Right now, where you are, gravity is pulling you right down towards the floor or the chair that you're sitting on. Okay, so that's why we don't float off into space, because gravity is this great big force that's pulling us all down, pulls everything towards the centre of the Earth. Our planet has got a gravitational pull from the centre of it, which pulls us all towards it. Okay, so that's what gravity does, but it's always pulling us down. Okay, magnetism, okay, can move things left and right, up and down in all sorts of directions because we can control it. You cannot control gravity. Gravity is always an uncontrollable force that's acting on us. So there you go. Gravity pulls things down, but magnets can pull things in different directions. That's your difference. And the similarity is obviously that they can both pull things because they both have a pulling force. Gravity is pulling us down, and magnetism is pulling objects left and right as well. So they both have a pulling force, but the difference being that gravity pulls you down. Let me just check how I actually worded it. I said gravity pulls things down, whereas magnets pull things in different directions. That's your difference. And similarity, they both have a pull force. So there you go. Right, thank you very much, everyone. That is the end of our Set B comprehension test for text for forces. So I do hope you've enjoyed that one. I do really love forces, one of my favourite topics in science. I've always loved that. But yeah, it's been really interesting. Thank you very much for tuning in. We'll be having a brand new text next week, so look out for that next Monday, and I will see you then.